showing you that we can do more than just hand calculations using R in this case. Of course, there are some inbuilt functions that can do this very easily for us. Let me do it in two different ways. So, Jeppe prepared your data for me, for us. So I put it here. Before I do this, let me show you. For now I have my 8 water measurements in my X here. So X is containing the 8 water measurements. Actually, there is a t-test function in R. Let's just try it here. If I use the t-test function, I get the following, just without any other options or anything, just t-test to my X data. I get something out. It tells me I'm doing a one-sample t-test. That is what you are taught today. That's the name of what you're taught today, as it is known out in the world globally. You have now been taught the one-sample t-test. However, what the heck is going on here? My p-value from before was point something, 4. Here's another p-value, very small p-value. Wow, what the heck is going on? Well, at least the result is so friendly enough as that it tells us what it has done. We didn't actually tell the function which hypothesis test should you do. So it just ran along and did one hypothesis test for us. The one that it did was true mean is not equal to 0. True mean is not equal to 0, it tells us. Meaning that it tested mu equal to 0 versus mu different from 0. The two-sided hypothesis test for the null of 0. But what the heck? That's not the one I wanted to perform. Well, that's how computers work. I mean, they tell you something, and you have to think about what they tell you, whether you can really use it or not. In this case, I cannot use it. That's not what I want. What I want in this case was, I wanted not to test mu equals 0, I wanted to test mu equal 2. That was the hypothesis test I wanted. Also, I did not want the two-sided hypothesis test. I wanted the one-sided where the alternative is that mu is greater than 2. So, there are the options, smaller, greater, or no option at all, which is then the two-sided test you get. Now if I run the same function with those options, I get the p-value. I get the t-test statistic that the t was 0.44 and the p-value was 0.33. Yeah, that's what I found before, right? So now it does exactly what I have shown you using those options. By the way, it also tells us the mean. Let's try to do it. Let's look at some. We have some male heights and we have some female heights. I usually claim that the male height is 180 centimeters. The average male height in Denmark is 180. Let's see if we can accept this claim, given the sample of you that I've done here. I have like 30 males or so participating in the study. Let's see. I used the t-test on the set of 30 male height measurements coming from you, right? I plug them in, I do the t-test of the claim of being 180 centimeters. I use a two-sided alternative, since if I claim that it's 180, if it's actually lower or actually smaller, I'm wrong, right? So that's an example of a relevant two-sided alternative. Am I right? At least based on these 31 measurements, using the 5% critical value, because that is the default used by, actually in the p-value, it doesn't make a decision, it just gives me the p-value, sorry. So it gives me the p-value of 6%. So if I use the 5% level, most commonly used, I could not claim I could not prove my claim wrong by these data, right? It's on the limit, so it's becoming a bit edgy, right? But that's the fact of life. That is also why things, results of studies and experiments are often discussed in the media, because it's not a black and white thing. If you get a p-value of 6%, you're very close to maybe have something, right? So you may discuss whether maybe you have something, at least on the risk level of 7%, you would have a result. But at the risk level of 5%, you don't have a result. I mean, that's the challenging part of this. It depends on the risk level, what the decisions you make are, right? The average height of you guys were actually closer to 183 centimeters. Look at something nice here compared to what I told you last time. You actually get the confidence interval for free coming out of this t-test function. Also, the confidence interval tells me that it goes from 179.86 up to 185. So the true male height, average height, is somewhere between a little below 180 and 185.5. That's at least based on this 31 sample data. Now, what I'm going to show you more exactly next time is the following. Now I will tell you, and then you can think about it. There is, of course, a very direct link between it's just showing this one. In this case, we used 99% level. I'm just finding this so I have a place to write. So, the hypothesis tests takes the average, subtracts, in this case, 20. This is just yet another example where mu equal 20 is tested, divided by the standard deviation over root n. The confidence interval is x bar plus minus the 95%, in this case, sorry, the 99.5%, and then I'm almost doing the mistake of the notation here. It's 0.05 to stick to this notation, times s over root n. Here is the hypothesis test. Here is the confidence interval that you were taught last time and which I repeated to you an hour and a half ago. Look at the building stones of the hypothesis test and of the confidence interval. It's something, it's the x bar and the s. It's the x bar and the s. X bar and the s. It's the n. It's the n. Then, in fact, if you did a hypothesis test, there would be a critical value for a two-sided hypothesis test. In fact, the critical value, as I've taught you, is this t statistic coming from, or the t percentile, sorry, coming from the t distribution, which is the same as the one used for the confidence interval. So, at the end of the day, doing confidence intervals and doing hypothesis tests are two sides of, as we say in Danish, of the same case. What's the English saying there? Two sides of the same box? I don't know what's... Two sides of the same coin? Is that what you would say maybe? Well, anyway, I think you get the point, even whether you're Danish or not Danish. It's basically more or less the same thing. I mean, it's not the same, but it's using the same building stones. It's the same stuff. We have the same observations, the same uncertainty considerations in both sort of tools. And there is the thing that the nice thing about the hypothesis test is the hypothesis test, you can come, can I use this value? Is this value valid? And then the hypothesis test can say yes or no. This value works. Is this a valid mu value? Yes or no. Is this a valid mu value? Yes or no. Is this a valid mu value? yes or no. I mean, I can reject or accept any try. I can try many different mu's and see which can I reject and which can I accept. The link is that the confidence interval actually provides the interval of all those values that are accepted by the hypothesis test, right? The confidence interval shows all the acceptable values. So there is an explicit direct link there. So that is the best way of actually thinking about the confidence interval. It gives you the valid values for mu, valid defined by being accepted or not in the hypothesis test. This is neat. Think about it. You have 2 weeks now to think about it and get used to it, right? So spend the autumn time in thinking about stats, right? I will for sure. I've done for 30 years, and when you get there, you cannot stop. It's a wonderful way of spending the holidays, right? Anyway, enjoy it. See you in 2 weeks from now. By the way, just keep on moving. Just the final thing. While you... the reason why, I'm sorry about to the females, that I only looked at male data. It's not because I don't like to look at female data. What we're going to be looking at next time is that, of course, the world does not consist of one sample situations. The world more often consists of multi-group samples that we want to compare. For instance, we can compare males and females by a t-test statistics. And there is such a t-test statistics, and I'll teach you in 2 weeks exactly how it looks, how to compare two different means, so you can also enjoy the thinking of this during your holidays here. See you in 2 weeks.